Hello everyone, today let's solve the sliding puzzle problem. When you first see this problem, you may feel that you don't know where to start, since the problem doesn't have any boundaries. However, if you treat it as a graph, the problem actually is quite easy. The breadth-first search algorithm used in graph is very suitable to solve this type of non-boundary problem. The key feature of breadth-first search is to explore the solution level by level. If there is no solution on the current level, it will go down to the next level until it finds one. Therefore, the only requirement for this algorithm is that there are defined choices on each level. In the sliding puzzle problem, there are maximum 4 move directions for number 0, so we can use breadth-first search to solve this puzzle. Let's start from an example. In the graph data structure, every movement corresponding to the one node. The initial arrangement is the first node of the graph. In this node, the number 0 has 4 move directions: left, up, right, and down. So we will have 4 nodes connect to the first node. Since none of these 4 moves reaches our goal, we then look at the next move choice after number 0 moves to the left. There are only 2 choices: up, down. Moving to the right will be back to the original place, so we don't do this moving direction. Again, we fill the node with this movement. They are still not our goal, so we have to examine the move choice after 0 move up. Repeat this procedure until we found our goal. To get the whole path to the goal, we just need to keep tracking the connection between the before and after move nodes. Now let's look at the code. In this code, we use stack to create the graph data structure and the dictionary to track all the moves. In dictionary, the key is the current move, and its value is the parent node. If the current move doesn't match our goal, we first find the location of the number 0. If number 0 is not on the first row, it means it can move down. If this down move hasn't been done before, we proceed this move. So append it to the left of the deck and add it in the dictionary. We repeat the same process for the up direction, the left direction, and the right direction. Then we pop the node from the right of the deck and check whether this node matches the goal. If not, we go through the above process again till we found the match. For the solution, we just do the reverse search to find the match. Okay, that's all for today. See you next episode.